Hello and welcome to your geometry recording for the week of November 14th. We're also in week 14. So this is our last full week before Thanksgiving break, so that's pretty exciting. And I'm going to talk a little bit more about due dates because of Thanksgiving break. So make sure you are watching the entire recording so that you don't miss my important announcements about due dates because of Thanksgiving break. So due dates are going to be a little bit different this week because of Thanksgiving break. So make sure you're watching the entire recording to get an update on that. And before I go into that, let's get us thinking about what we have learned in Unit 3, quadrilaterals. So Unit 3 is focusing on quadrilaterals. And so far, we've been looking at parallelograms and then breaking it down further into some special types of parallelograms. So remember, parallelograms have some characteristics or properties, such as opposite sides are parallel and congruent, opposite angles are going to be congruent, diagonals will be congruent. And then as we get into the special types of parallelograms, they're going to have even more specific properties that include all the properties of parallelograms. So if you look at this chart here, what that means is a square is a special type of parallelogram. And then a square has some more additional properties, as well as having opposite sides that are congruent and opposite sides that are parallel. In a square, we find that all sides are congruent and that all of our angles are 90-degree angles, which makes a square. A square can also be considered a rectangle as well, because a square has all the properties of a rectangle. A square can be considered a rhombus. Oh, I'm giving away the answers. I'm going to stop here. Let's look at the warm-up questions. So what I want you to do is use this chart to answer these questions with sometimes, always, or never. So first, is a square a rhombus? Is that sometimes, always, or never? And then a parallelogram has four congruent angles. Is that sometimes, always, or never? So go ahead and click pause and try to answer these questions on your own, and then when you're ready to check your work with mine, click play. All right, so let's look at the first one. It says a square is a rhombus. So a rhombus, the properties of a rhombus are that opposite sides are all going to be congruent, and that's true always of a square as well. So in this case, a square is a rhombus. That statement is always true. A square is going to be considered a rhombus, and that's always true because it has all the square has all the characteristics of a rhombus, so it is considered a rhombus. What about a parallelogram has four congruent sides? Well, we know a rhombus doesn't have four congruent angles. And in order for them to all be congruent, they would have to be 90-degree angles. So a rhombus does not have 90-degree angles. A rectangle does, though, and a square does. And remember, all these are types of parallelograms. So because a rectangle does and a rectangle does not, or I'm sorry, a rhombus does not, that puts us in the category of sometimes. Because rhombuses do not have 90-degree angles, and rhombuses do not have 90-degree angles, rectangles do, so it is sometimes that a parallelogram will have four consecutive angles. These guys do. This one does not, so it's sometimes. All right, I'm going to go on to the next slide, so if you need more time, go ahead and click pause, otherwise I'm moving on. So this week is going to be a little bit shorter week of assignments, and one of the reasons is that I'm going to have your assignments this week are going to be due on Friday. So usually our assignments are due on Monday, but because next week is Thanksgiving break and the whole week we have off from November 20th to November 24th. We have that whole week off. I'm going to make it so your assignments are due on Friday. Again, I'm also adjusting the amount of work so that there's less assignments. So since we have an earlier due date, I'm adjusting the amount of work I'm giving you to compensate for this. The reason I'm doing this is I want you guys to be done before break and be able to really enjoy your break. If you do need time to work over break, that's okay. As long as you get your assignments in by Sunday, the 26th of November, that's fine with me. I'm going to start grading your work on the Monday that we come back from break. That's going to be the November 27th. I'll start grading. So as long as you beat me to when I start grading by getting your assignments in before I start grading, you'll be good to go. So if you do need some to work over break, you can. Remember, Schoology is going to be available to you. Schoology will be available to you over break. I will not be. So your teachers are not going to be available over break. But you are more than welcome to work in your classes, especially if you're behind and you need to get caught up. Thanksgiving break is an amazing opportunity to get caught up. Heads up, we have about 5 weeks. I think it's a little less than 5 weeks left in the semester. And remember, once the semester is done, there's no late work that is accepted. Once the semester's done, that's your grade for the semester. So start thinking about where you want to end and what you want your grade to be and some goals and ways that you're going to work to achieve your goal grade. So if you have any questions about due dates this week or with Thanksgiving break, anything about that, just send me an email, let me know. So we're going to work this week. We're going to work on Unit 3, Session 8. We're going to look at properties of kites and trapezoids. So we're going to look at some additional types of quadrilaterals. And then we're going to start wrapping up Unit 3. Really, Session 8 is the last session where you're going to be learning new material in Unit 3, and then we're going to do a fun quadrilateral project where you guys are going to be creating fake Facebook profiles of a quadrilateral of your choice. So again, it's a fake Facebook account, and directions are in this week's folder. All right, so I'm going on to the next slide here. Again, we're finishing up new content for Unit 3 this week. And just a heads up that the Unit 3 test is coming your way after Thanksgiving break. So after Thanksgiving break, we'll do some review and then you'll take the Unit 3 test. And again, remember to be working on any missing assignments if you have any, and that if you do submit missing or late work, you're sending me a message. Otherwise, I will not know to grade it. Moving on. All right, so trapezoids. It's another type of quadrilateral. We've got 1, 2, 3, 4 sides. So what makes this four-sided figure a trapezoid? So a trapezoid is a quadrilateral with one pair of opposite sides that are, one side of opposite sides that are parallel. So in order to be a trapezoid, we only need one set of opposite sides that are parallel. Remember that little arrow lets us know that these two sides are parallel. So for a trapezoid, it's different than a parallelogram, right? Because parallelograms had all opposite sides were parallel. Where a trapezoid, we only have one pair of opposite sides that are parallel. And then a special type of trapezoid is an isosceles trapezoid, where an isosceles trapezoid is a trapezoid that has a set of congruent legs. So we've to be a isosceles triangle, we're going to have a set of congruent legs. So we see a tick here and a tick here that lets us know that these legs are congruent. So make sure you write down in your notebook the properties of trapezoids and then what makes something an isosceles trapezoid. I'm going to go on to the next slide now, so if you need more time, go ahead and click pause. All right, so some trapezoid theorems that we can use to solve for problems where there's some unknowns. So if we have a trapezoid that is an isosceles trapezoid, Here we go. It's an isosceles because we've got a set of congruent sides. Then each pair of base angles is congruent. So each pair of base angles. What is a base angle? A and B, those are base angles. So A and B, those angles would be congruent. And then our other set of base angles, which would be angles D and C, they're going to be congruent. So your base angles are congruent. And then adjacent angles are supplementary. So that's true, remember, of parallelograms as well. So that same thing is true, is that any two adjacent angles are going to be supplementary. So if we add any two adjacent angles, they're supplementary. Remember, supplementary adds up to 180 degrees. All right, so let's solve a problem with what we just learned. All right, so we are told that this quadrilateral PQRS is an isosceles triangle. And I know that because there's a tick on this leg and a tick on this leg, and these two legs are parallel. So the two legs having one set of parallel legs, we know it's a trapezoid, and then because we have a set of congruent legs, we know it's an isosceles trapezoid. And we are given that side RQ is 2.16, so I'm going to go ahead and label that. This side here is 2.16, and this side over here also has to be 2.16 because we know that those sides are congruent. And we're also given this angle here. The angle S is 50 degrees. And we are given the task that we need to find the remaining angles measurements. We need to find every other missing angle measurement. So, where can we start? What do we know about the base angles of isosceles triangles? So that would be these two, angle R and angle S, are base angles. What did we just learn about base angles? They're congruent. So this angle here would also have to be 50 degrees. So the measurement of angle R is also 50 degrees. Can I find angle P and Q? Do I have enough information to find angles P and Q? I do. Remember, we also learned that adjacent angles are going to be supplementary. So let's look at this angle and this angle. They're both adjacent. They're right next to each other. So we learned that the measurement of angle S plus the measurement of angle P is going to add up to 180 degrees. Well, we know that the measurement of angle S is 50 degrees. That was given to us. This is our unknown that we're going to solve for. So we're going to subtract 50 from both sides, and that's going to give us the measurement of angle P, which would be what, 130? So this angle right here would be 130 degrees. Do I have information now to find Q? We sure do. We know that base angles are congruent, and angle P and angle Q are both base angles, so they're going to be 130 degrees as well. The measurement of angle Q would also be 130 degrees. And we can check our work. These two angles here, since they're adjacent, have to add up to 180 degrees, do they? 50 plus 130 definitely equal 180, so that checks out. So we were able to find all of the missing angles using what we just learned about trapezoids, and especially isosceles trapezoids. I'm going to move on now, so if you need more time, go ahead and click pause. So some more trapezoid theorems. Let's talk about the diagonals. So in an isosceles trapezoid, the diagonals are going to be congruent. So that means the distance from A to C is going to be equal to the distance from B to D. And we can also use the lengths of the diagonals to determine if in fact we're working with an isosceles triangle. So if you can prove that your diagonals are congruent, then you can say, hey, guess what? We've got an isosceles trapezoid. So remember, you can always work backwards too. So if we can prove that our diagonals are congruent, we can prove that we've got an isosceles trapezoid. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. Let's see here. Let's only do one of these. Let's do number 1. So number 1 says that we've got, let's look at what we've got. We've got a set of parallel lines, so, and only one set of parallel lines, opposite parallel lines. So we know that this must be a trapezoid. And then I've got one tick here and one tick here letting us know that KJ is equal to LM. So we know that we're dealing with an isosceles trapezoid here. So let's label some of our givens. So J to N, so J to N, so from here to here is 10.6. So I'm going to label that as 10.6. Let's always label your diagram so you get a good visual. And NL, so from N to L, we've got a length of 14.8. And we want to find the length of KM. So we were given some information about parts of the diagonal, and then we need to find KM. So remember, since this is an isosceles, we were given the information that this is an isosceles triangle. So because it's an isosceles triangle, we know that the diagonals are going to be equal to one another. So the diagonal from K to M has to be the same length as from L to J. Well, do we know the length from L to J? We do if we add up. So JL or LJ, it doesn't matter. I just wrote down a random segment. We know though that, let me go move this stuff up here. We know that LJ is going to be equal to 10.6 plus 14.8. So what's the total length of that segment? So 10.6 plus 14.8. I'm just plugging this in my calculator and I get 25.4. So I know LJ is 25.4. So if LJ is 25.4, then guess what? KM must also be 25.4. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. So in session 8, you're going to learn some additional information about properties of trapezoids, but I also wanted to just introduce the last type of quadrilateral you're going to learn about in Unit 3, which is kites. So what makes something a kite? And it's the shape of kites that you fly. That's what a kite is. But specifically, what makes something a kite? You're going to have two pairs of adjacent sides that are equal. So two pairs of adjacent, so not opposite anymore, because opposite sides, look, if we look at the opposite sides of kites, they're not equal, but the adjacent sides will be. So you're going to have two sets of adjacent sides that are equal. The angles are equal where the sides meet, so the non-vertex angles. So that means you're going to have this angle here and this angle here are going to be congruent, and that's it. So the vertex angles are considered where you've got your congruent sides where those meet. Those are considered your vertex angles. So the non-vertex angles, these two right here, are going to be equal. Those angles will be equal. And then when we draw on our diagonals, those are going to meet at right angles, at 90-degree angles. Remember, a right angle is a 90-degree angle. So the diagonals intersect at 90-degree angles. And the diagonals also bisect each other. So meaning these ones right here. So this segment from here to here is going to be congruent from this segment from here to here. Not this one though. And then the diagonals bisect the angles. So each angle will be cut. These two right here will be congruent. So like from here, and these two will be congruent, and then these two angles right here will be congruent. So just wanted to introduce what kites are. You're going to learn all the properties in this week's assignments and in session 8. So just a brief introduction to kites and trapezoids. I'm going to stop here before this recording gets too long, and we're going to throw up the key phrase assignment. So in this recording, you learned a lot about trapezoid. I want you to tell me, how is a trapezoid different from a parallelogram? So how is a trapezoid different from a parallelogram? And that's it. So have a great rest of your week. Have an awesome Thanksgiving break when we get there. And let me know if you guys have any questions about the due dates. Remember, make sure you listen to the portion of this recording about the due dates, because it is a little bit different this week with Thanksgiving break coming next week. So I want to make sure that you're not missing the due dates. So make sure you listen to that bit about the due dates for this week's assignments. And that's it. Have a great rest of your week. And let me know if you have any questions about the due dates after you've listened to the full recording.